Okay, example 1 on set 67. Simplify 1 over negative 4 plus the square root of 3. And what you're going to notice here is there's a square root in the denominator. And that's an issue. We don't like that, right? We don't like square roots in the denominator. Up till now, what we did to fix that, and don't write this down because it's wrong. But what we did to fix that in the past was we multiplied top and bottom by the square root of 3, right? That's what we would have done in the past, right? Again, do not write this down. This is not right. If we attempt to do what we did in the past to this problem, the top becomes the square root of 3, no big deal. The bottom, the square root of 3 times the square root of 3 makes a plus 3, right? But the square root of 3 times negative 4 makes negative 4 times the square root of 3, and we still have a square root in the bottom. They didn't fix it. So what we did before doesn't work. So structurally, you have to recognize this for what it is in order to understand how to do it. What gets rid of a square root is squaring things, right? So if, for example, the square root of 3 squared is equal to 3, right?
Yeah.
Right? And we have a little thing that we learned back in Algebra 1, and I think we revisited in Algebra 2 already. It's called a difference of squares. It looks like this. X squared minus y squared. All right. If we have a difference of squares, the factored form of a difference of squares is x plus y and x minus y, right? If we have a sum and a difference of the same two objects, you create perfect squares being subtracted, right? And these things, when you have a sum and difference of the same two objects, this is called the conjugate. That's the conjugate of that, and that's the conjugate of that. Same objects, different signs. So, for example, if we have negative 4 plus the square root of 3, and I multiply by negative 4 minus the square root of 3, we're looking at multiplication of conjugates. And according to difference of squares, if I do this product, I should get negative 4 squared minus the square root of 3 squared. That's what I should get if I FOIL it, right? Negative 4 times negative 4 makes negative 4 squared. Inside product positive 4 square root of 3, or inside product negative 4 square root of 3. Positive 4 square root of 3 minus 4 square root of 3. What happens? Cancel. And then last times last, square root of 3 times square root of 3 is square root of 3 squared being subtracted because of the opposite signs. Alright? And notice, just like that, that makes 16. That makes minus 3. 16 minus 3 is 13. That has no radical on it. So that's the idea here. We're going to multiply by a conjugate. We're going to fix it. So, in general, when you see a binomial denominator with a radical in it, multiplication by its conjugate is going to fix it. Like so. Oh, why that eraser? So, top and bottom multiplication is what it's going to be. On top is just either a FOIL or a distributive property. On the bottom, again, we already know it's going to be perfect square minus perfect square. So, 1 times this just makes negative 4 minus the square root of 3 on top. On the bottom, again, you could FOIL it out if you want, but just keep in mind, the shortcut is just FL. We're doing a difference of squares multiplication. The outside and inside products cancel. So F times F, negative 4 times negative 4 makes positive 16. L times L, positive times negative makes a negative. Square root of 3 times square root of 3 makes 3. And just like that, we end up with negative 4 minus the square root of 3 over 13. That is equivalent to 4 plus the square root of 13, or sorry, the square root of 3 over negative 13. Alright, just keep in mind that if you're checking the back of the book to verify you got the right answer, you got this, they got that, they mean the same thing. I changed all the signs on top, all the signs on the bottom, equivalent fraction happens.